we are going to, as we have seen in the previous video, we have discussed about the mass storage management. Now we are going to discuss about the IO subsystem. What is the purpose of having IOS with respect to the hardware devices from the user? The main responsibility of having this IO subsystem is nothing but they will be managing the memory with respect to buffer. Buffer is nothing but it is like a temporary storage where the data transmission will initiate to another end by using this particular buffer storage, where it will avoid overlapping and everything. Then we have cache, which is nothing but the storage part of the data where fast transfer and the performance will happen. Then snuffling is nothing but the overlapping of the one job with the another job. These are the various responsibilities availed by the particular IO subsystem. Now we will be having the particular interface that will be available with the particular device driver. This is nothing but a USB, IO device, peripheral devices and everything. Each and everything will have a general device driver interface. Now we will be discussing about the production and the security. Production, which is nothing but we may apply any of the mechanism to control the particular access of the processor or the user with respect to the resource in order to define the particular OS. So whatever data you are transferring with respect to the memory, memory processor and everything, we have to have a effective mechanism to control the access of the processor with or the user to the resource in the operating system. Now we have to apply the security to secure the particular data. It's nothing but we have to defend the particular system against external and internal attacks. As the attacks includes, we have denial of service, worms, virus, identity theft and theft of service. Nothing but denial of service is nothing but whatever data. Example, if you're taking a Alice and the Bob, if Alice is sending a particular data, if the data is not reached to the particular destination of Bob, there must be an intermediate who theft that particular data and prevent it from the denial of service to the destination. Then we have worms. Worms is nothing but the illegitimate data or the unwanted data that will be injected while the particular Alice sends to the Bob with the particular data, which is nothing but a oops or the unnecessary data which is included with the normal data which is initiated from the source to the destination. Virus is nothing but modifying the data or corrupting the data. Now we will be having identity theft or theft of service, nothing but stealing the particular data when it is transmitted from the source to the destination. Now with respect to the security, we can able to determine the particular user with respect to user identity, user ID, group identifier and privilege acceleration. User identity is nothing but user. We have certain identities that is being assigned, which is nothing but a user identity. Security identity contains name, associate number, one per user. For each and every user, there will be an identity that will include name and the associate number. Then we have a user ID that is associated with all the files of the processor with that particular user in order to determine the access control. Then group identifier, which allows the set of users to be defined, and we have to control and manage all the user which is available inside the particular group identifier. Now we have a privilege acceleration. Acceleration is nothing but providing or changing the particular rights to the particular files or the users who is trying to access the particular data or managing the particular data. Now we have a kernel data structure. In the kernel data structure, we have a various data structure strategies being applied. Here we have a linked list which may be a singly, doubly and circularly. For each and every linked list, there will be a two things which has contained data and the tail. Tail which connects the next data and the tail of the next data will be connected to the data, which is nothing but a chain of connection that will be in a singly linked list formation. If it is doubly means we have a three block of cells that will contain data, null and the tail. The tail will connect the next data and null will connect to the next block of null, which is available in the next data. So it is nothing but we will be having a forward and the reverse transfer between the two data which are interconnected. Then circularly, which is nothing but we have a data which is connected with the tail with the next data, but lost data which is not been nullified, that will be connected to the first data block which is available with the particular tail. So it is nothing but a circularly linked list. Now we have a binary search tree. Binary search tree is nothing but it is a balanced searching tree. Here we will be having a left root node and left and right tree, where the values which are present in the left and right is nothing but left which is less than the right node which is holding the particular value. The performance search of this particular binary search is nothing but big O of n, which big O is nothing but a notation which is used for measuring the performance of this searching algorithm. Now we have a hashing function that will create a hash map. Is nothing but we will be having a particular data which will be held with the address of 0, 1 to n. The value which is held in the particular address of 3, which is having a hash function with the particular key which is integrated with the particular value, where the hash map will be created for this particular hash function, where that will hold the particular data. Bitmap is nothing but we will be having a number of strings which is represented with the binary digits, and also in order to represent the bitmap and the hash function, we have to include some header files which is nothing but list.h, kfifo.h and write binary tree.h. These are the some header files which can be included for programming this particular searching and the hashing function bitmapping concepts. Now we have a computational environment with a traditional strategy. In the traditional strategy, we have only one standalone general purpose machine. But most of the systems are interconnected with other through this particular internet. Here the web access to the internal system is portable, so that the particular transferring of data will be happen between each and every nodes which are interconnected with one another. Then we have a client which have a network computer which is like a web terminal that able to initiate this particular transferring of data and also to make the particular system to be standalone. Now all these particular computers which are interconnected will be via wireless networks. Example, it may be a home system which uses a firewall to protect the particular home system from the internal attacks. For the mobile, we will be using various mobile devices as well as smartphone, tablet, etc. What is the main use for differentiating the traditional laptop with this particular mobile? It's nothing but we have extra features of OS, nothing but GPS, gyroscope and everything. Here we have a new type of application that can be allowed inside this particular mobile computing environment is augmented reality. And we have various mobile technology that can be used for connecting the data and for initiating the transmission. Nothing but IEEE 802.11 wireless like Wi-Fi, GPS, GSM and everything. The main mobile OS initiators are Apple and the Google Android. Now we have a distributed computing environment. In the distributed computing environment, we have a collection of heterogeneous system network together, where that is being initiated with the network communication path, which is commonly used for TCP and IP, nothing but transmission control protocol with internet protocol. With respect to this particular TCP connection oriented protocol, we can initiate them with a LAN, WAN, MAN and PAN. Nothing but local area network, wide area network, metropolitan area network, personal area network. Then the network operating system will provide certain features with the particular system across the particular network which is there in the remote area, and we can able to initiate the communication for exchanging and allowing the system to exchange and managing the particular message. Now we will be having a client server computing environment. For making this particular client server computing environment, we have a smart PCs, nothing but HPC or any supercomputer, where they may have multiple systems that will be connected with a particular server that will able to initiate the request generated by the clients. So here we have a server with a network of multiple systems that will be interconnected with a particular network with a particular server that will manage the server, that will manage the particular server, that will manage the particular various systems of client, laptop, desktop, and smartphone and everything through this particular network. Now we have a peer-to-peer computing environment. Here we have multiple clients that are interconnected with each other. It is nothing but a distributed system. It is like a distributed system where all the clients are connected with one another, where point to point, peer-to-peer does not able to distinguish with a client and peer-to-peer also is being initiated, but overall it is a distributed environment where we will be having a where they can initiate with peer-to-peer or all the nodes that are interconnected, where they can be initiated with multiple clients with multiple server or multiple servers with multiple clients. The nodes can be joined with peer-to-peer network. Now we have a register that will be looking for the lookup services in the particular network, where what are the nodes are connected with this particular, each and every clients will maintain a particular lookup service, where what are the nodes being, what are the clients being connected with that particular client, and it can able to broadcast the services and response through this particular discovery protocol. Main example is Napster and the Untula. Now we have a virtualization. Virtualization, it is a aid of this particular distributed client server and peer-to-peer. In virtualization, it will allow the OS to run multiple applications with other OS which is not been fit with the particular memory of this particular current OS. Emulation is nothing but we can have the particular emulation being used where the CPU storage and the resource can be used for various other targeted types, and but it will be bit slow, but there will be a effective execution of this particular computation in this particular virtualization environment. But the particular computer language cannot be compiled with the native code with the interruption, where it will be going for the emulation. For the virtualization, they will be having running with the guest, and it can be compiled with the CPU, which is a virtual one. The OS, which will be using the particular VMware, which is running with the particular thing, where they will be virtually machine based OS that will be initiated with the particular running of the application in that particular virtual environment by utilizing the current CPU. For the virtualization, we can involve laptop 2 and the desktop for multiple OS to explore and compatibility. The Apple laptop running with Windows, guest and everything wherever the virtualization is possible with certain applications being running on that particular OS. Developing an app with multiple OS without having multiple systems is being initiated with this particular virtualization. Now we have a VMM, nothing but virtual machine manager, that will be currently running to initiate the particular host where there is no general purpose host being available for this particular virtual server or virtual OS. Now this is a design of this particular virtualization environment where that particular normal process will have a kernel, hardware and the processor that will be embedded with a particular virtualization with a program interface like VMware, where the VMware will have the same hardware partitioning can be utilized with a virtual machine manager with multiple VMwares, like multiple OS with multiple kernels that will be attached to run multiple process which is been running on each and every OS. Here we have 3 OS which is been embedded with this particular virtual machine manager to initiate multiple processor with this particular server. Now we have a cloud computing. Cloud computing is nothing but we will be making a delivery and the storage with various apps that will be running across the particular network. The main example of having this cloud storage is nothing but Amazon EC 2, which is able to handle thousands of servers and thousands of virtual machine and storage enormous storage capability through the internet for the usage. There are various cloud computing storage, which is nothing but public, private, and